All right, so let's go ahead and knock out this part 2, and we'll pick up with part 3 in lecture when we meet again on Wednesday. So I'm just kind of, again, this course, Exploring Physical Science, just kind of dabbles in each of the disciplines. Now we're talking about astronomy. I'm trying to hit the highlights of astronomy. Astronomy is kind of near and dear to my heart, so let's see what else we think is important. Need to talk a little bit about the planets, and the way this works, you can kind of see them represented here, is I'm going to draw a line here. These guys, I'm going to put a T for terrestrial. These inner planets are our terrestrial planets. I'm going to try to put a T. Oh well, you know what I mean. And they are what we say rocky. And then these guys, these 4 are our Jovian planets. I'll put a J for Jovian. My T's and J's kind of look alike on this. But anyway, Jovian, these are gaseous planets, so you can't really stand on them. And we already kind of talked a little bit about the characteristics of each. These Jovians all have rings, although Saturn has the most predominant rings. I'll put a J here for Jupiter. This is Uranus. This is Neptune. Here we have M for Mercury, Venus, Earth, Mars, and this is Earth's moon. So I'll talk a little bit about each one of those. This is a table. I don't know if you can see it very well on this video, but you should have it in your notes so you can kind of see it, with some important characteristics about the terrestrial planets. Notice that we've got the definition of an astronomical unit is the average distance between the Earth and the Sun. So you can kind of see how far away these are from the Sun in astronomical units. Then down here are the Jovian planets. And as we look at one of the things about spacing, and hopefully you kind of noticed that in the lab we did this past week, was the spacing of the outer planets is just crazy away from the Sun. So I think that's kind of fun. Over here, this last column, how many moons does each planet have? Well, this is Earth's 1 moon. These are the 2 moons around Mars, but they're very kind of ugly. And then we get to our gas giants, and check this out. Look at all the moons that the gas giants have. Don't have time to touch on everything, obviously, but if you're a news junkie at all, and a space junkie at all, you know that there have been a lot of spacecraft that have either orbited or interacted with objects in our solar system, including other planets. So this is just kind of a menagerie of some of the awesome sort of vehicles that have visited planets. Now, you're familiar with NASA. You might not be as familiar with ESA as NASA, but ESA is the European Space Agency. So that is so cool, so cool. So let's kind of look through each of the planets that orbit the Sun. Does this Mercury not look like the moon? I think it totally looks like the moon. So Mercury is the closest planet to the Sun, and it is what we say it's not active anymore. So it's a dead planet in that it has no liquid in it near its core. Now, the thing about Mercury, a few things, is one is that it basically has no atmosphere, and the reason for its lack of atmosphere is its size. It doesn't have the gravity to hold the gases in place. The other thing is that Mercury rotates so very slowly so that the side that's next to the Sun is very hot, but the side that is away from the Sun, even though it's close to the Sun, the side that's turned away, like the nighttime side of Mercury, is very cold because it rotates so darn slowly. We have 2 planets that are closer to the Sun than us, and of course that's Mercury, and the other one you would tell me is Venus. And so the way that works out when we see Mercury or Venus in the sky, it's always going to be close to the Sun because of that. Mercury, you can't see any surface features through a telescope, but actually, if you've ever heard that planets don't twinkle, that's kind of true because they have more of a component to them from our perspective. They're larger. Stars twinkle because they're small and intense. So all of the planets, including Mercury, the reason that we see them is not because that they have some sort of glowing or heat in their inside. The reason we see them all has to do with the sun. Actually, light from the sun hits the planet, and then that some of that light is reflected back to here us on Earth. So that's how we see the planets. Oh, each of the planets I'm going to kind of say a little bit about. And one of the things, if I ask you where is the Caloris Basin, then you should tell me the Caloris Basin is on Mercury. The Caloris Basin is just kind of a cool impact crater, and there you go, there's the Caloris Basin. It's so awesome, though, by the way, is that it hit this side at the time the impact occurred. It hit this side, and if we look on the back side of Mercury, it's got all these jumbled hills that basically the impact, the energy from the impact carried through the planet. That's pretty cool. The next planet after Mercury is Venus. Venus is very bright in the sky. Now remember, Venus is going to be close to the sun, again, kind of like Mercury. So when I say close to the sun, that means like you'll finally be able to see it just as the sun sets, or for a little while before it also sets in the west, or in the east shortly before the sun rises, you'll see Mercury and Venus. So Venus is very reflective, and the reason it's reflected has to do with its clouds. It's got very reflective clouds. And in its cloud structure, the most common gas is carbon dioxide. Let's see, I said it's viewed near the sun. But Venus then actually goes through phases. We're going to talk about phases of the moon. And if I were to ask you phases of the moon, you'd probably say, well, there's full moon, there's a quarter moon, which looks like a half moon to us, there's a crescent moon. And as it turns out, Venus also goes through those phases because of how it's orbiting the sun and how we're viewing it from our orbit around the sun. So Venus, it looks like it has been active in the past, and it may have this kind of strange activity where basically it kind of builds, the heat inside of it builds up over time, and then it kind of remelts the surface, the solid surface of Venus, and then it kind of resurfaces itself, which is kind of interesting. The daytime and nighttime side of Venus is actually, unlike Mercury, remember Mercury has these extreme temperatures between the nighttime and the daytime side in Mercury. Venus actually, it's about the same if you're in the daytime or the nighttime side. It's just hot, H-O-T, hot on Venus. And the reason that basically it stays constant even in the night, so hot in the night, has to do with its thick clouds. Now Venus, I think I mentioned in class, Venus is one of those, is the most extreme example of a planet. If you look down the North Pole, it's actually going what we say retrograde. So it's actually, what I'm saying is it's going clockwise, it's spinning clockwise around on its axis of rotation instead of counterclockwise, retrograde. And again, the reason that would have been is because early on it was, excuse me, hit by almost a planet-sized object, and it spun around 180 degrees. This up here, now one of the things about all the planets is have they been visited, and actually Mercury has had some nice spacecraft inserted in orbit, so Mercury has some great pictures. Venus has also had some spacecraft in orbit around it too, but this actually is a photograph of a Soviet Union spacecraft that landed and sent back pictures for just a little while. So this is a picture of the surface of Venus. Is that not cool or what? And as far as I know, then nothing else has landed on Venus except for that one back in like 1970. Now Mars is a very, very busy planet, and I'm really not quite sure why so many spacecraft visit Mars, but they do, and that's fine. No, I'm just sort of kidding. Well, so anyway, Mars, you can see this actually looks like kind of like an ice sheet, and as it turns out, that's not ice, that's carbon dioxide. and it's frozen carbon dioxide. So Mars has a thinner atmosphere than Venus, but thicker than Mercury, and it, like Venus, is mostly carbon dioxide. There is a feature on Venus called Valles Marineris, and it's kind of centered around the equator, and it looks like it's a humongous Grand Canyon. And I'm thinking the dimensions, instead of like our little Grand Canyon, which is it's on my bucket list, this rift at the equator would go across the United States, if I'm thinking of that right. Let's see, what else do we have? Oh, it's also got a very large, like what we'll call a caldera, like a kind of an extinct now volcano remnant, which would be, I believe, about the size of Missouri. Mars' axis of rotation is tilted similar to the Earth. It's tilted almost 23.5 degrees. Maybe Mars has been visited so many times, because look at that. I mean, that looks like it could be someplace on Earth. That's on the surface of Mars. Now, I give Mars a hard time because it's a busy place. All sorts of spacecraft inserted around orbit of Mars, and all sorts of spacecraft has landed on Mars. And we have rovers on Mars that are sending back. You can actually go online and see somewhat real-time feed of these rovers sending back images. It's just amazing. All right, so Mars, actually, a few things. Mars has these cool dust storms, and they actually look like little dust devils that scoot across the storm, or excuse me, scoot across the surface. It is so very cool. Now, Mars has 2 moons, but boy, they do not look like Earth's moons. And I kind of tease that they are moons that only a mother planet could love. These moons, called Phobos and Deimos, Fear and Panic, are probably most likely just what we say captured moons. Unlike the Earth's formation of the Earth's moon, and we'll talk a little bit about that, was actually a piece of the Earth splashed off and formed the moon, what we know and love call our moon. These were just kind of like random things that I think got stuck in Mars orbit and have been there ever since. So I've never seen it, but like I said, this actually is like at the pole of Mars. Now, Mars will go through seasons just like Earth goes through seasons, since its axis of rotation is tilted. And so you'll actually see a polar cap down here, and then you'll see the polar cap up here at the different time of year for Mars. So I've not really seen much surface feature on Mars. Now, with that said, I should say this late summer, I want to say, Mars is going to be at a relatively close position for us to see it here on Earth. So you might see a hubbub about that. Go out, find a telescope, come out to the Whitty Observatory. The asteroid belt is after Mars, and so here we have Mars is the last terrestrial planet. Jupiter is the first Jovian planet, and then we have these little dots. Now, one of the things is it looks like when we see these, it looks like we'd have a hard time crossing the asteroid belt, because they're so close together, but they are actually spread hundreds or thousands of miles apart. And most of them, like this slide says, are the size of tennis balls. Oops. Some asteroids have their own moon. How cool is that? Asteroids actually, asteroids are not only located in the asteroid belt, so I think we're going to talk about that here in a minute. But asteroids are of interest to land a spacecraft on and to mine them. Isn't that kind of cool? These asteroids that are located between Mars and Jupiter actually are not scary to us here on Earth, because they're kind of confined there. But we'll talk about an asteroid that does cross Earth's orbit. Now, if all the asteroids, some people say it's like, well, if I take this and kind of combine it all together, do I make one planet? Is that the missing planet between Mars and Jupiter? Well, in fact, it would actually not be that large. You're talking about the size of maybe the Earth's moon if you were to combine all the mass. And combining all the mass would be difficult, because Jupiter, the big bully or friend, however you want to talk about it, Jupiter actually kind of makes it hard for that stuff to kind of combine into one piece, one object. So this is one of the objects in the asteroid belt. And we actually don't call this an asteroid. This is a dwarf planet, just like Pluto is a dwarf planet. And it's called Ceres. And Ceres was actually visited by a spacecraft. And I've not, as I said, supposedly, I mean, I've not seen an asteroid. But now the reason, or the way we see asteroids are the way that we see planets, in that the sunlight has to hit the asteroid and then come back here, so to Earth. Now, I'm not trying to say you can't see it through a telescope, but it's on my bucket list too. Jupiter. So we did the lab this week, and hopefully you kind of have a sense for how big Jupiter is relative to Saturn, Uranus, and the terrestrial planets. Jupiter's the big guy, but Jupiter's not nearly as large as the Sun. It would have to be 60 to 80 times its size now to have been large enough. We'll talk about the formation of stars to be its own star. Jupiter has lots of moons, but these are its special moons, okay, called the Galilean moons. They go, and this is from Jupiter outward, so this is the closest: Io, Europa, Ganymede, and Callisto. That's how I pronounce them right now, anyway. These crusty moons, I would believe Europa, Ganymede, and Callisto, these outer moons actually are icy, have an icy crust with liquid water underneath them. Jupiter, the first Jovian planet, all the gaseous planets have no solid surface. You can't go stand on them. But if you fall far enough into their core, they do have a kind of a rocky little core. It's like they swallowed a terrestrial planet. You can see on Jupiter kind of these bands, and one of the cool things I think about Jupiter is that actually they're called, I think they're called bands and zones, and they go opposite directions. Okay, they go alternating directions. Is that not crazy? And you can almost see where that actually would lead itself to some interesting kind of dynamics with regard to storms and such. And kind of the reason they alternated going left and right like that is because they are clouds that, how do I say, they have material kind of rising from the warm planet, cooling as they rise, and then sinking back down, and it kind of gives this alternating bands. Now, one of the things that I might put on the test is, where is the Great Red Spot? And you would tell me it is on Jupiter. So actually we have the Great Red Spot being shown right here. There for a while was let's see if I have it here. Nope. There for a while was the Red Spot Junior, and I think that might be it. But the Red Spot, the Great Red Spot, has been around for hundreds of years. Okay, so it was reported being seen by, I can't remember, was it Hooke? Okay, so the Great Red Spot actually is something I have seen through the telescope. That's kind of fun. And it takes about, is it 9 hours, 10 hours, I want to say, for Jupiter to spin once on its axis of rotation, which is amazing since it's so big. But then you can actually, there are apps to say what time will the Great Red Spot be visible. Saturn, of course, one of the things about Saturn is its beautiful rings. Now, if I were to ask you on a test, though, hopefully you would say that all gaseous planet has rings. Saturn's is just the coolest. This is a neat picture, is this right? Taken by the spacecraft Cassini, looking back at Saturn and the rings of Saturn, and actually Earth and its moon in the distance. That's so cool. Saturn has lots of moons. One of its moons is of particular interest to us, and it's called Titan, and we've actually placed a spacecraft on Titan. Titan has like a water cycle, but it's not water, it's methane. Another cool moon around Saturn is Enceladus, and Enceladus actually has been caught in the action of spewing these, what starts out as liquid on the moon, and then it crystallizes in the atmosphere, in space. Makes these water geysers. That is so cool. Okay, so this is Titan. Okay, and this is Enceladus. You can kind of see the geysers. That is so cool. Okay, the rings. The rings actually are not a solid like skirt. Actually, they're little particulates, and they're relatively bright from here on Earth. Us here on Earth, and that's because they actually have an icy component that makes them pretty darn reflective. If we study Saturn's rings, you're going to see that there are gaps, and actually there are, I can see this is a ring. There's a big gap here called the Cassini division, and then there's a gap here around the 8 outside we call the Encke gap. That Saturn's axis of rotation is tilted, and so as we see it as Saturn orbits more slowly around the sun than Earth, as Saturn orbits the sun, we see a different kind of perspective of this tilted rings. Okay, viewed through telescope, the rings can be outstanding, and we're able to see several of the large moons. Like there's an app for that too. There's an app for everything. There's an app to actually see where Titan will be relative to the planet Saturn, where Enceladus would be. We mentioned around Jupiter, it has those 4 large moons that Galileo saw, the Galilean moons, and there's an app to show you where those would be. And they look like little stars, but they are moons orbiting the planet. So after Saturn, we have after Jupiter and Saturn, they're kind of similar color because they have similar chemistry. And then we have Uranus and Neptune, they're similar in color. We have our blue guys. So they are both blue due to the presence of methane in their atmosphere. Uranus, though, oftentimes you'll kind of see it drawn like this, and I'm going to kind of draw in its axis of rotation. Notice that its axis of rotation basically lies in the plane of the ecliptic, so it has these weird sort of crazy seasons. I like this image because you can kind of see a ring around Saturn, because I told you all Jovian planets have rings, and all Jovian planets actually have moons too. The ring actually was seen by what's called occultation. Now, in astronomy, if you hear something about, an occultation is going to occur, if something is occulted, or in the case of astronomy, if it's occulted, it's blocked out. So what happened is that the rings actually blocked out distant stars. Like if we're over here, if this is Earth, we saw a star blocked out by material from the ring, and that's kind of how we knew that Uranus had rings. So I have actually seen Uranus and Neptune through a telescope, and it's kind of awesome. They look like a little blue disk. So after Uranus we have Neptune. It's also blue due to the presence of methane. Neptune actually has, and I'm not sure if I think it's gone now. Instead of the great red spot, it has the great dark spot. And it was a storm also in the atmosphere of Neptune, but did not last as long as the one, well, from our perspective anyway, around Jupiter. But the thing about Neptune is the wind speeds are the strongest in the solar system. That's pretty cool. So all of the gas giants, including Neptune, have moons in orbit about them. This is one of the moons that orbits Neptune, called Titan. Triton? Oh, Triton. Anyway. The thing about this moon actually is that it is going backwards. Anytime you hear the word retro, think kind of backwards, retrograde rotation, which means actually at some point it's going to smash into the moon and smash into the planet Neptune, and probably give Neptune another ring. Neptune again looks like a little blue disk. Okay. So outside of Neptune now is Pluto. So Clyde Tombaugh actually found Pluto in that he saw, against background stars, he saw this object, Pluto, and it's actually orbiting the sun. And the thing about Clyde is that his ashes were actually placed inside of a spacecraft called New Horizons, which flew by Pluto. Oh, what year was it? Seems like just the other day, but it's pretty exciting. A blink comparator the comparator means that he would compare night after night and see that that object was moving. So that was 1930, and then in 2006, and actually related to the finding of other objects like Eris beyond Pluto, even larger than Pluto, that was also orbiting the sun. We either needed to promote Eris and these other things that are out, what we call the Kuiper Belt, to the status of planets, which means we'd have hundreds of planets now, or we needed to come up with a different classification for Pluto and Eris. And so we came up with a different classification. So Pluto is now classified a dwarf planet. And Pluto is actually more similar to a comet than it is similar to Neptune, Uranus, Saturn, and Jupiter. So it's got definitely this rocky and icy component to it. Now, Pluto is an awesome dwarf planet. It has its own moons, and they're shown here. So, I mean, it is an awesome dwarf planet. I mentioned New Horizons. That was bringing the ashes of Clyde Tombaugh. And if you get a chance to, I don't know if I have anything here, check out New Horizons photos. They are amazing. One of the things that strikes me is is that the planet Pluto actually has, just because of its terrain, a feature that kind of looks like a heart on it. Okay, so these will be due. Let's see, we're meeting again next Wednesday. If you forget that they're due, that's fine. I'll just make them due Friday, but bring them Wednesday if you can. All right. So beyond Pluto is this place that harbors these objects called Kuiper Belt objects in the Kuiper Belt. Now the Kuiper Belt, think of the Kuiper Belt as basically lying in the plane of the ecliptic. Now beyond the Kuiper Belt is the Oort cloud. And think of the Oort cloud as kind of spherical with the sun in the center. Now what's in the Kuiper Belt and the Oort cloud? Well, kind of what we say leftovers from when the solar system formed. These objects have an icy, they're rocky, and they have an icy component to them, and they are gravitationally associated with the sun. Every once in a while, these objects that are in the Oort cloud or the Kuiper Belt can actually be kind of pushed on their way or tugged on their way to come closer to the sun. And it's like, who could do that? Well, our planet Jupiter, or a passing star. Is that not awesome or what? Anyway, if they're gravitationally kind of redirected, then what can happen, if this is the sun in here, which it is, and this is kind of the Kuiper Belt, and this is the Oort cloud, they can come into the sun, and as they come into the sun, we'll talk more about comets here in a minute, they start to fizz, okay, and they will actually make a streak in the sky. Oops, there we go, going the wrong direction. So comets. Comets are icy, rocky objects. Again, most likely found where it's nice and cold beyond Neptune's orbit, so in the Kuiper Belt or the Oort cloud. And we said that our sun turned on about 4.6 billion years ago, so actually they've kind of been out there for 4.6 billion years. Is that not awesome or what? It's so awesome that actually, and I don't know if I have a thing here, that we have sent spacecraft to chase comets to get some of that material to analyze, okay? So comets. I mentioned a minute ago that comets actually can be sent from the Kuiper Belt and the Oort cloud closer to the sun. As they come close to the sun, this is the fizzing I was kind of talking about, okay? So that is material from the comet itself. So as you might imagine, the comet's getting smaller and smaller and smaller as it kind of fizzes or vaporizes. Now the thing is that the comet, it's booking right through space, but you figure it's got a lot of space to cover if it's coming out from beyond Neptune, okay? And so actually we don't see it like zip through the sky. We see it move over the course of several weeks against the background stars. And if you're interested in this sort of thing, actually on the internet are maps to kind of show you where the comet will be night after night. So these are just pictures of comets. Isn't that cool? You can we're going to talk about two different tails. Well, they're already shown here. Let's see, how's this go? The ion tail is kind of the straighter tail, and then it has a dust tail that's kind of arched. And the nucleus is the rocky thing in the center, okay? And the kind of the bubble thing around it is called the coma. So those are that's the anatomy of a comet. So you can kind of see the straight ion tail and kind of the curved dust tail. Now the way it works is the sun, I know the sun must be here because the sun is blowing what we call solar wind, and actually that's what moves the tail away. That is so cool. So we're kind of seeing that phenomenon here. Notice that this comet is going this way around the sun, but at all times you kind of see the tail moving away from the sun. The other thing is, can you see that the tail is much greater when it's here closer to the sun than when it's away? Now I get mixed up in when we've covered this thing. I think we talked about, did we talked about perihelion yet? So actually this is when it's closest to the sun, we call it perihelion. Perihelion. Okay. Some comets, and there are actually videos of this, get too close and they can't make the orbit, and they're called kamikaze comets, and they fall into the sun. I think that is so cool. There's Comet Ison. You can kind of see the two tails. Each comet has its own kind of little personality. Comet McNaught, Comet Lovejoy. Oh, so cool. Another thing I want you to know in this class is something called meteors, and meteorites. And actually, they are written in the order in which they occur. Meteoroid is in outer space. A meteor is really short. That's that streak of light that falls as a chunk of something, probably rocky, maybe icy materials falling through the Earth's atmosphere. That's the streak. Okay. And this is the thing that I'll put 3 here over meteorite. This is what you pick up. If a piece makes it through Earth's atmosphere, that's what you pick up. So meteoroid is outer space. Meteor is the streak. A meteorite is what you pick up. Okay, so this is actually a picture of a meteorite. Are you serious? Meteorite. It's amazing. This is a meteorite impact crater in Arizona, Winslow, Arizona. But like this slide says, and when we look at the moon, we're going to be seeing all sorts of impact craters, not all that big. But the Earth's, most of the Earth's impact craters have been resurfaced because of our, kind of our, what we call plate tectonics over time, or weathering, or... So you've probably heard of a meteor shower before. So if meteors are the streak, then a meteor shower is when you see a bunch of streaks. Well, on average, whether you're not in a meteor shower or just normal sort of conditions, about every 10 minutes, a piece of space rock will fall through the Earth's atmosphere from your perspective, and you should be able to see a streak. Okay, so about every 10 minutes, you should be able to see a meteor. Now, a meteor shower occurs, and down here you can kind of see the sun, and here's the Earth passing. Now, we need to go counterclockwise, right? So it looks like this, right? Counterclockwise. So here's the Earth orbiting the sun, and here, right here, the Earth is going to pass through. This right here is the line of a comet. This is the orbit of a comet. So when comets get close to the sun, we said comets vaporize. And as they vaporize, they leave what I call little crumblies, little pieces of themselves. So then when the Earth passes through that debris, that gives us what's called a meteor shower. It's just extra rich stuff falling through the Earth's atmosphere and gives us a bunch of streaks. Okay, so this is going to actually occur a certain time of the year. Why? Because it's a certain position in our orbit around the sun. So each year we have some awesome meteor showers at specific times of the year. There's a great one I have a list coming up in August, a cool one in December. So this is one of those photographs where you kind of open the shutter and kind of catch the multiple things happening. So these are streaks then. These are all material coming from, we actually call this a radiant here. So if you're trying to catch a meteor shower, they say, well, look in this region for most of the meteors to be coming from, the origin of them. And the way they do the radiant then is it's going to be from a constellation. And we'll talk a little bit about constellations later, but then so the meteor showers are named after the constellations they appear to come from. Speaking of then, I bet you've heard of, Orion. So there's a meteor shower called the Orionids, okay, and you can kind of see about the time around October 22nd. That's when Earth is going to be pushing through comet debris, and it's going to look like the streaks are coming from the constellation Orion. So that's how that works. Some of these are more meteors than others. So I know the Geminids is awesome. Like I said, that's in the winter, and the Perseids those are the two major showers. They're very, very major. Now, in order to catch a shower, a few things: you want really dark skies, but the other thing is that if the moon is bright at all, then that totally messes up your meteor shower. All right. So let me know if you have any questions. Thanks for playing along.